Right. Welcome. In this tutorial, we will learn how to use the Excel Analytic Solver to run a Monte Carlo simulation. So let's imagine a business situation where you are the owner of a coffee shop and you decide you want to start selling um, yogurt parfait, and you trying to find out what's going to be the profits if I start selling this new item, and what's the probability of loss? Will I make money? What's going to be the standard deviation of profits? And you have, for this new item that you're trying to sell, it could be anything. In this case, I'm saying yogurt parfait, but you could want to start selling tea that you never sold before. You might want to start selling magazines. Take any example. We are taking one example, and let's evaluate what is the cost associated with it, what kind of demand we will get, and how can we use Excel Analytic Solver to make a good decision. So let's get started. There are 4 parts to a good structure in solving any simulation problem. Not any, many simulation problems. So let's start with that. There are certain things that will be given to you. So whatever is given, you would want to write those things down. Whatever is uncertain, you would then want to write those things down. And you would be interested in certain things like profits. So what is the output, or what is it that you're interested in? And then based on whatever output you're interested in, which depends on this uncertain input and certain input, you might be interested in some business metrics. Like you might be interested in profits, expected profits. So you could have profits, but you might be interested in profits, average profits or expected profits over a period of time. So these are the 4 areas: what's given to you, what's uncertain, what output you're interested in, and what are the business metrics that you really care about to make a good decision. And what you typically want to do for any given model, with adding these 4 structural elements, you want to also write in 1-line summary, what are we trying to do with this model? Like, what is the 1-line summary of this entire work? Because then when you go back to this Excel sheet, you can actually quickly refresh your memory as to what's going on. So I'm going to say coffee shop owner trying to estimate expected profits from a new item they are selling. Let's say yogurt. Yeah, so that's what they're trying to do with this simulation. So this owner might have some information that's given to them. So let's write down what is the information that's given, or certain variables. What's given to us, let's say, is cost to make yogurt parfait. Yeah, cost to make yogurt parfait is given to us. Once we know that, what we can do is write down that the cost to make yogurt parfait, let's say, is $2. And then let's say you know that you can sell it at, let's say, $4. So you could say this is in dollar per unit. So you know what this number 2 stands for. It's $2 per unit. Selling price in dollar per unit, $4 per unit, right? And let's say you couldn't sell some, you made a lot more than what you sold, then maybe let's say you also can make money by salvaging it to someone who, a seller who's a buyer who's willing to buy it from you and resell it, right? So let's say you have uh, an ability to sell unsold yogurt parfait per unit as let's say $1. You made it at 2, you will sell it at 1, and that seller will maybe sell it at 150, and then they'll make some profit. So you write all of the things that are given to you, yeah? So that's the starting point, yeah? Write down everything that's given to you that is fixed. This is certain. There could be many more things that are fixed that are given to you, so you'd want to first write down all of those things here, yeah? Once you write down all of the things that are certain, then you know these things won't change for you, but they're important to calculate profits, yeah? But they're certain, but they're important. Then certain things are not known to you. Let's say how many customers or demand for your yogurt parfait. You don't know how many people will come up, but you know through experiments, let's say as an owner, and this will all be given to you. As an owner, you could have some past experience that says, hey, I can expect the demand to follow a normal distribution. When you know the mean of that demand, let's assume that to be 200 people or 220, and you know the standard deviation to be, let's say, 25, and you know that minimum or the lower bound of how many people will buy yogurt parfait would be, let's say, 100, and then the maximum or the upper bound of how many people will buy on a given day is 300. So you have some characteristics of the demand that you can model using a normal random number that comes from a normal distribution if you knew the mean and the standard deviation. And let's say you can approximate it based on your past experience, or if it's already given to you that the demand is expected to be 220 for this yogurt parfait, and standard deviation is 25 with lower and upper bounds. Even if lower and upper bounds are not given to you, if you're given at least mean, average demand, and the standard deviation, then you can estimate the demand using a normal distribution. So the way you would enter and make this demand for a given day is by going to distributions and entering common, select common, and then go to normal. So it will allow you to make this cell dynamic, and you can specify, I want the mean to be 220 for my normal distribution, and notice that the mean has now changed to 220, and I want the standard deviation not to be 1 but 25. So you start to see that the standard deviation is factored in as well, and you're also in this case given the lower bound. So I'm going to say the lower cutoff is 100, and you're given the upper cutoff as well, so you can specify that to be that from Excel, yeah. So you're given the lower cutoff, upper cutoff, mean, standard deviation. So now what you've done here is you've configured it so this normal distribution is what's going to be used to populate this cell. Why this cell? Because I was on this cell. That's when I click normal distribution by going to distribution, common, normal, and then I configured it. Once I hit save, you will see that this is now a normal distribution. This cell will have values that come from a normal distribution with mean 220, standard deviation 25, lower bound and upper bound. And that's, if you don't want to go to this UI and select, you can also write this formula directly. Psi normal C8, which is the mean D8, which is the standard deviation, and it takes in the lower bound and the upper bound as side truncate parameters. Yeah. So that makes this cell dynamic. And if you now hit function F9, you will see that this value changes. Function F9, you keep clicking function F9 or pressing function F9 on your keyboard, you will see that this value is going to be dynamic. So now all of a sudden you can model using this cell a dynamic set of demand that you will expect on any given day. Yeah, so now you have modeled an uncertain variable using a normal distribution. What would be helpful is to also color code all of these key areas of the structure. So I'm going to mark uncertain variables as blue. I will mark output variables or profits as gray. I'll mark business metrics as yellow, and I'll slowly build this together. Yeah. So now we have modeled the demand. Let's try to find out profit. That's what we're interested in. Yeah. We are interested in profits. But if you're interested in profits, what does the profit depend on? It depends on how many items we sold. How many did we sell? Well, it depends on not only the demand of the items that we sold, but also like how many did we order. So we have one other part of the structure here, which is decision variable. This is uncertain variable. Decision variable is a variable that we control. Like in this case, quantity we ordered or quantity we made of yogurt parfait. Yeah, we know that this is what's the characteristics that we anticipate. Based on that, we can take a guess. And let's say we say I'm gonna go for 260, slightly above the mean, but definitely lower than the upper bound. I'm gonna mark the quantity that we order, which is under our control, as green, because this is something that we can enter. Tomorrow morning I can change this to 220, and dependent on the demand I can control this. So let's say I go with 260. So how many items did we sell? If we ordered 260 and we got 233 people showing up to buy our goods, well, it's going to be the minimum of these two. So I'm going to say min, hit tab, select the first, comma, select the second. Now that gives us how many items we can sell. Notice that it's going to be, if we had 260 ordered but 225 people show up, well, we can only sell how many people show up, because that's the lower of the two. But if we had ordered only 10 units and 216 people showed up, well, you can only sell how much you have. So this formula seems to be working. So you can change this back. And if you hit function F9, you will see that this will keep changing based on how many you ordered and how many you had demand for. Yeah. So items we sold is needed for the sales revenue, right? So sales revenue is how many items we sold times the selling price for each item. Yeah, so that's the money we made. Is that the only money that we make? Well, we're also given that we can salvage whatever is unsold, so we can make money from items that are unsold. So items unsold. Well, items unsold will be how many did we order? We ordered 260. If it is greater than how many people showed up, then the difference between the two will be the items that are unsold. If not, it's zero, right? If more people showed up, than what we have, then we'll sell everything and then there's nothing unsold. So if the quantity that we ordered is greater than the demand for the yogurt, then the difference is going to be what is unsold or excess inventory. But if it's less, then it's zero, right? If we ordered less, then how many people showed up, then all of them is going to eat up each of the items that we have, so it's zero. So once I have this, I can have refund revenue. Yeah, so I have sales revenue, I have refund revenue. How much refund will I get? Items unsold times how much money I make from them. And then I will have profits. Profits would be how much money I make from selling at regular price, how much money I make from salvaging, minus the cost. What is the cost? Is the quantity of items that I ordered times the price I paid for each of them, right? If you can only order numeric, you can also, one way is you can say, I'm going to round this to the nearest integer. And so now you will make all of this as numeric. So demand is numeric, and then you will see the profits to be whole number as well. Let's say you can't order or make 1.1. So I'm going to mark this as I'm rounding it for now to get a close approximation of how many items are in demand and how many will be sold. So profit is what we care about, and that's an output variable. I'm going to mark this gray. Say this output variable section. This profit specifically is the output we care about, but it depends on all of these intermediate items. Once we do that, we can easily calculate the expected profits. Expected profits is how much money this person will make from all possible values of profits. And so what we now need to do is tell Excel that, hey, I'm not going to keep clicking function F9 button 1,000 times. I'm going to tell it to run this simulation for 1,000 times and monitor this cell that I'm interested in, because that's needed for expected profits, standard deviation of profits. So what I'm going to do next is I'm going to tell it to monitor my output cell. So I'm going to go to Analytic Solver, Results, Output in Cell. What it does is designates the currently selected cell as the uncertain function by appending psi output. So you see here, it now is by adding this output, psi output, it's going to start measuring all the values of profits. Now I have told it to monitor the output. And what I'm going to do next is I'm going to tell it to run this simulation for 1,000 trials, meaning get me 1,000 values of this demand. I have Latin hypercube as sampling method. It's much more efficient to get a representative sample, especially when we're using this in Excel. And I'm running one simulation. And now with this configuration, I have marked it to run this for 1,000 times. Having done that, if I run the simulation by simulate run once, it would run this 1,000 times, and it gives me expected profits. Mean $398, standard deviation $71. The lowest 5% chance or the worst 5% outcomes to be $277, still positive. 95th percent, $520 of profits. And I can start to see various percentiles as well. Expect you to make money even in the lowest 1% one percentile, right? So it's all positives, especially with this quantity that I'm ordering, 260, very close to the mean. I expect to make a lot of money. So you can start to see some of these statistics. And what if we want to start to show mean and standard deviation of profits here, which is, it has also already calculated. Let's hit save, and let's get expected profits and expected standard deviation of profits to be outputted here. So to do that, I'm going to do results, statistic, mean. It says it returns the mean value of the specified uncertain function. The mean or the average value is the first moment of the distribution of trials. Yeah. So I'm going to say I want to show expected profits or mean profits. Select mean, and first it's going to ask me select the cell, output cell for which you want to compute this result. So I'm going to say first click, it's going to be here because this is the one profit is what I want to calculate the expected profits of. So I'm going to click here. Once I click, it gives me another prompt. It says now select the cell where you want the statistic, the expected mean profit to be placed. So you say here. So all that does, it says I'm going to calculate mean profits for B18, and it's going to show it here. It's the exact same value that we saw in the pop-up. If you want to see that pop-up results of all of the visualization, you double click the profit cell and you hit yes, and it'll show you that same value here, $398.215. Similarly, if you want to show standard deviation of profits, you can go to results, statistic, standard deviation, std dev, select the output cell for which you want to compute the result, profits. Where do you want to put the results? In here. So now you have the two variables that you really care about. I'm going to mark this based on conventions that we've used as yellow. So these are the business metrics that we care about. These are the input variables that we care about that are given to us, uncertain variables, decision variables, output variables, business metrics. Simulate run once. Once you do that, you will get the results. Yeah. So what if now you want to run this simulation for different quantities? Yeah. Let's say you want to run this simulation for you want to run simulation 1 for 200. Let's say you want to run simulation 2 for 250, simulation 3 for 300, simulation 4 for 400, simulation 5 for 450. Yeah. Say you want to run this simulation not just once but 5 times. So you specify what you want to do here, and you change this static value of quantity of 260 to this dynamic value. We want all of these to be inputted here. So what we're going to do is we're going to go here and we're going to say size sim param, which is in a sense providing the simulation parameter. For every simulation that I run, I want to give it all of these values, yeah, as a parameter. So I click the cell, drag all the way here, it'll populate E21 to I21, which are all the values here. And I close the bracket. And now all of a sudden you see that it's a dynamic cell now, which will give you the simulation that you run all of these parameters from 200 all the way till 450. Having specified that you want to run 5 simulations, you also want to configure it. So you go to options and say, hey, I want to now run not just one simulation for 1,000 times of 1,000 different values of demand. I want to run 5 different simulations because that's what you have here, 5 simulations. And that will make it run 5 simulations, one for each of these quantities. Yeah. So you hit OK. And once you configured it, you have to run the simulation. It's expected to see all of these NAs because it has not computed the results. As soon as you change the options, it will require you to run the simulation because the configuration has changed. So you would run the simulation, you would see the values pop up, but the other thing now you will see is you will see a drop down here which you didn't see before of different outputs which corresponds to different values of inputs. So for example here, it shows us here for simulation 1, the quantity 200, the mean profits is 390. If I select simulation 2, notice that it has changed this value here to 250, which corresponds to 250. Similarly, simulation 3, simulation 4, simulation 5, and so on. All of these values are changing based on the simulation you picked. So now it has run the simulation 5 times, and it has also gotten different values of profits, expected profit, and standard deviation. And now let's extract all of that from all of these 5 different simulations and show it here. So the way we do that is we will copy these formulas here because that's how we've calculated the simulation. We're going to paste it here. And we'll have to make some changes because here it will now do psi mean of E19 because it's a copied formula. So we will say, hey, I want you to calculate the mean from here. Yeah. So B19. And I want to lock this cell because then I can copy this formula for all of these simulations. So all my results for profits would be here. And I want to tell it that use the simulation run 1 as the second parameter, because remember if you had to select the drop down, you said simulation 1 mean, simulation 2 mean. So now this is how we're going to specify, give me the output expected profits psi mean from simulation 1. So you specify that with a comma. And similarly we will fix this cell to reference B19, so $B, $19, and then the first simulation. Yeah. If we now run this, it will work fine. Yeah. It'll show us what is the output expected from the first simulation, and that will match up. Now if you copy this formula, it will get you the results from all of the simulations. You run the simulation again. So in one snapshot, now you can compare profits, standard deviation of profits in one place. Yeah. So all we did was we changed the formulas that we copied here to reference the simulation that we are looking at. The results would be all calculated in this cell, so we're going to fix that cell. If you want to calculate, let's say, probability of loss, so then it's basically all negative numbers here. So you would use results, range, and then go to target, which gives you the cumulative probability of target value in the distribution of trial values for specified uncertain function. So if you specify 0 here, it'll give you the cumulative probability of all values up until 0. But 0 is break even, so we'll give it something slightly less than 0, like minus 0.0001. That'll give us a cumulative probability of all negative numbers. Yeah, so I'm going to use target. Be very careful. Here it's telling you in prompt directly to place this, click where you want the target to be. Do not click anywhere else. And then you would have to manually modify this to say, hey, I want you to calculate target for B19. And I want to calculate the cumulative probability of everything until a small negative number. Yeah. So if you run the simulation now, you will see that there's less than 0.3% chance of negative profits or probability of loss here. I'm going to copy this formula and try to extract that for all the cells once I fix the cell B19. So remember that B $19, and I'll have to specify that I want the output to be from simulation 1, and then I can copy all of this to here, run the simulation, and we will get the values. So notice this number, if it is a very small number, it'll show you 0, so you might want to change this to the significance of how many digits you see after the decimal. And you will now see probability of loss right there for all of these values. And if you start to now increase, say, hey, I'm not gonna the probability of loss starts to happen at a higher value, especially if you know what the mean demand is, and if you're very close to it, the probability of loss is very close to 0. But let's say if I were to change this to, let's say, 500, yeah, and rerun the simulation, now all of a sudden the probability is like 1.6%. Yeah, you can also change this to a percentage, so that gives you, and then add some significant values. So you quickly realize that probability of loss in this scenario with standard deviation of 25, lower bound of 100, you'll at least get 100, and upper bound of 300. That's what your characteristics are, yeah? So that's how you calculate probabilities. You can also calculate minimum value, maximum value that you can expect in this through various other characteristics like statistic mean. So then you specify, if you go to measure or measure range and then minimum, then you get the minimum of the profit, the maximum of the profit from all of the trials. So you can calculate many more statistics that you might care about. Select the output cell for which you want to compute the result, where you want to place the result, so that gives you the minimum. Similarly, you can get the maximum range, minimum, and then we have maximum. So I'm going to calculate maximum for this, output it here, and if I run the simulation, it will fix that. So change that to $B, $19. Copy that over like last time. But also specify, I think what we forgot this time around is the simulation parameter. So B19, that looks right. B19, that looks right. I'm going to copy this over now. And then if I run the simulation, now I have, what do I expect? The minimum, the maximum, and so on. Yeah. So, but if you now order, let's say 300 units, you can see the value 300 here, and you can see what you can expect for that. So like this, you can start adding many more business metrics, probability, like percentile numbers, like the lowest 5% outcome, and so on and so forth, to find out what business metrics you care about to simulate using Monte Carlo simulation. Yeah. So the key things to recap here is having a good structure is very helpful. And then you can also validate that it will start adding as you start marking uncertain variables, like let's say demand is uncertain, so B9 is marked here. B19 is the output variable that we care about, the uncertain function. Uncertain input leads to uncertain output. So B19 is our output profit. And then we are saying we want to calculate statistics for B22 to B26, which are all of these statistics. And we also want to calculate these statistics from E 22 to I-26. So it's added each of these statistics that you want it to calculate. So you can check and validate that they've been added here. If you're adding multiple sheets with multiple models, then they will all get added to multiple sheets. So you see sheet 1 has these variables, but if you add another sheet and more variables, then it will keep adding more variables, and it will rerun the simulation for all the sheets. And there are limitations on what the solver platform can do here. So ideally what you want to do is you want to just have one model in one sheet and one Excel document. If you have another model, just create another document, because then you will not hit some of the limits that we have here with this platform default configuration, which can run 2500 trials and certain fixed number of simulations, which is 2500, but and also certain fixed number of uncertain variables and statistics that it can measure. So that's how you run a Monte Carlo simulation to find out expected profits, expected standard deviation, probability of loss, min, max, and so on. You can do many different statistics. At the same time, what's important is to notice that we use the normal distribution to model this. Sometimes your uncertain variable could be better modeled using a binomial distribution. If it's a yes or a no answer, true or false, they'll buy or not buy. If you want to start to model using that, whether someone shows up or not shows up for their reservation. So all binomial distributions are a better one for that. You might even have a discrete distribution that says, hey, I can only expect certain number of possible demand characteristics. Either have 5 people show up or 10 people show up or 20 people show up, and each of them have their probabilities. Then you would model this using a discrete distribution. And there are various distributions given here. The most important ones are the normal distribution, uniform distribution, and some of these are continuous distributions, and some of these are discrete distributions. So binomial, that the one I was talking about, is under discrete. And there is a psi discrete, which is a discrete distribution with certain outcomes with certain probabilities. You would use discrete. You also have integer uniform, like if you want to model how many people buy t-shirts, then it's integer outcome. So then you would use integer uniform. And so on. So there are various distributions here, so check them out. The common ones are the normal distribution, binomial distribution, integer uniform, discrete distribution, and discrete maybe uniform if they have the same probability. Those are the ones that we commonly use. But depending on what variable you're modeling, you would want to use the right distribution. Yeah, so that's the key. You might also have multiple outputs you care about. So you'd want to, in this case, we care about only profits. But let's say if I'm interested in customer satisfaction. By that I mean that anyone who wants to buy the yogurt parfait should be able to buy it, meaning no one should leave my shop without buying. Then maybe that's another output variable that you care about. So you could have multiple output variables. But remember, each of these business statistics are built out of output variables. So you care about certain things, and then you want to build business statistics or metrics around those output variables that you care about. Profits, customer satisfaction, reducing the amount that you have to salvage because you care about environment and not really selling or throwing stuff around or wasting stuff, right? So there could be so many things a business would care about. So those all will go here in the output variable of interest, and you can create and calculate multiple simulations using SciSim parameter, configuring the options to run multiple simulations, changing each of these formulas to now look at all of the simulation outputs, and then in one place quickly decide, oh, if I want to really maximize my profits, I should go with 250, 405 on expected profit. If I want to reduce and have the minimum standard deviation of profits, I should go with 200. Yeah, that's the minimum. Someone might be like, hey, I want to look at risk versus reward. So divide profits, divide by standard deviation of profits. So risk, reward to risk ratio. Maybe that's something that then you can calculate that in one go and find out, oh, that's what I'm interested in. Someone's interested in not having any loss, then any values here are good, except that they shouldn't go above 400, or somewhere between there is where it'll start to get to negative profits and chances of having losses. So that's the high level of running a quick Monte Carlo simulation using Excel Analytic Solver. The key things around structure, uncertain variables. If you follow the structure like this, then it's easier to model many difficult problems. So just slowly start writing them down and then running the simulation.